The air, surprisingly, didn't reek of farm. Instead, a faint, earthy aroma hung in the crisp morning.
Welcome, a voice chirped, pulling me from my reverie. Dr. Anya Sharma extended a hand. I'm Anya, lead engineer here. And you, my friend, are about to witness the future.
Her passion was palpable. Instead, before me lay a meticulously organized industrial marvel, humming with power.
Most people think of agricultural waste as just that, waste. But here, we see opportunity. Every ton of manure, every whiff of methane isn't a burden. It's untapped energy. It's a gold mine.
Rapid cuts depict rising emissions, polluted water, and vast animal waste.
The solution lay in biogas, capturing methane, transforming it into clean electricity and nutrient-rich fertilizer.
Our journey began at the rear, where a fleet of specialized tankers rumbled in. This is where the magic truly begins.
Anya led me to an immense concrete receiving bay. Fresh cow dung, the unsung hero of our power grid.
As the first tanker offloaded its viscous, dark cargo, I felt a strange shift within me.
I knew it. It's exactly where the calculations said it would be.
The receiving pit, a cavernous maw, hummed with a low, hydraulic thrum.
The screen shimmied, effectively sifting out larger debris. Stray bits of hay, small stones, even plastic.
Our logistics are precise. Fresh biomass yields better. We can't afford delays.
As a second tanker began its discharge, I watched the thick, brownish-green slurry cascade.
Beneath the screen, the filtered dung plunged into the receiving pit, where powerful agitators began their work.
Consistency is key. Too thick, it won't flow. Too thin, we dilute methane potential.
From the receiving pit, the slurry was drawn into the slurry mixing zone for further refinement.
We emerged into a cavernous hall, dominated by colossal, insulated tanks. They hummed with a deep, almost sentient thrum, a sound that vibrated through the floor.
And here, Dr. Sharma announced, is where the true magic unfolds. A microscopic army performs vital work.
Inside these sealed giants, away from oxygen, a microscopic army systematically breaks down organic compounds.
It's a delicate balance. We constantly monitor temperature, pH levels, and internal pressure.
That's where the raw biogas exits, a rich blend, typically 55 to 65% methane.
Retention time is also critical. We aim for 25-30 days, maximizing biogas yield.
From the digesters, the nascent power manifested. A spider web of pipelines converged.
A giant, dark gray gas dome billows gently, capturing raw biogas.
This is where the real refining begins. Raw biogas, laden with carbon dioxide and hydrogen sulfide.
The H2S is particularly problematic. It's corrosive and highly toxic, so its removal is non-negotiable.
Our first purification stage is desulfurization. Here, the raw biogas passes through biological units.
Specific microorganisms oxidize the H2S into elemental sulfur and water. An elegant, environmentally friendly solution.
Once desulfurized, the biogas, still laden with CO2, continued its journey.
Methane is insoluble, but CO2 readily dissolves, allowing us to effectively wash out the carbon dioxide.
A quick whip pan reveals semi-permeable membranes, intricate and selectively filtering.
The final product, purified high-grade biomethane, CH4 98.2%. The transformation was complete. The next door hissed open, revealing a spectacle of controlled power. This was the generator hall. 4 colossal internal combustion engines sat like sleeping giants, their polished chrome gleaming.
A network of thick, insulated pipes snaked into their sides, carrying purified methane directly.
Each of these engines is a powerhouse. That rotational energy is converted into electrical energy.
Engineers meticulously monitored every aspect. We constantly adjust output to match demand and grid stability.
Beyond the generator hall, a different kind of transformation was underway.
We were led to large, open-air lagoons, surprisingly devoid of pungent odor.
This is our organic gold. After methane extraction, what remains is incredibly potent fertilizer.
All essential plant nutrients are present, but in a more stable, readily available form.
Farmers eagerly purchased it, using it to enrich their fields. It's a complete cycle.
Cows eat grass, produce manure, we extract energy, and the enriched manure helps grow more grass.
Anya has beautifully articulated the heart of our operation. What started as an ambitious dream blossomed into reality.
We've seen the full circle here, from waste collection to clean electricity and nutrient-rich digestate.
Every step is optimized for efficiency, every byproduct utilized, proving that waste is truly just a resource.
The impact on our community has been profound. For years, cow dung was a burden.
Farmers are no longer just selling milk. They're selling their waste, generating new income.
Their reliance on expensive chemical fertilizers has plummeted, boosting profits and enriching soil naturally.
Beyond the immediate economic benefits, the environmental dividends are immense. We are directly tackling climate change.
Capturing vast quantities of methane, a greenhouse gas far more potent than carbon dioxide.
This factory alone offsets thousands of tons of CO2 equivalent annually, reducing dependence on fossil fuels.
And this, my friends, is just the beginning. This is a scalable blueprint.
A dynamic montage shows diverse rural communities transforming waste, creating jobs and food security.
The methane miracle represents a paradigm shift in how we view waste, energy, and our environment.
This isn't just a power plant. It's a beacon for a greener, more prosperous, and truly sustainable planet.
From humble beginnings, a beacon of sustainable innovation rose, transforming waste into opportunity.
The earth, revitalized, now yields bountiful harvests.
Every morning, specialized trucks collect the raw material, ensuring optimal conditions for transformation.
Trucks back up to these ramps, gravity and low-pressure pumps, ensuring complete transfer.
The vibrating screen meticulously sifts out debris. Any foreign objects can disrupt the delicate balance.
We call this our pre-treatment phase. It's crucial for protecting our pumps and microbial balance.
The agitators churn steadily, breaking down larger clumps, ensuring an even distribution of water.
We aim for a specific dry matter content, typically around 8 to 12%, for optimal flow.
More sophisticated grinders further refine the mixture, reducing particle size for anaerobic bacteria.
The air grew noticeably warmer, carrying a faint, earthy scent. Here, the true magic unfolds.
Within these sealed giants, a microscopic army performs its vital work, transforming waste.
Each of these digesters holds approximately 2 million liters of prepared slurry, maintained at 37 degrees Celsius.
Perfect conditions for our specialized consortium of anaerobic bacteria. A delicate balance.
It's a multi-stage process: hydrolysis, acidogenesis, and most crucially, methanogenesis, converting compounds into methane.
The pH, for instance, must remain within a narrow range. Too acidic, methanogens slow down.
That's where the raw biogas exits. It's a rich blend, typically 55 to 65% methane.
The beauty of this system is its efficiency. These bacteria are incredibly resilient. The biogas purification plant glows at sunset, pipelines leading to the sleek structure.
Giant, flexible gas domes, like colossal balloons, billowed gently, capturing the raw biogas.
A spiderweb of thick, insulated pipelines snaked upwards, converging into a primary artery.
This is where the real refining begins. The H2S is particularly problematic. Its removal is non-negotiable. Our first purification stage is desulfurization. Here, specific microorganisms oxidize the H2S into sulfur and water.
It's an elegant, environmentally friendly solution, producing a harmless byproduct. The air has a faint tang.
The biggest challenge is separating methane from carbon dioxide. The biogas now continues its journey.
Biogas flows countercurrent to pressurized water. CO2 readily dissolves, allowing us to wash it out.
For even higher purity, we use semi-permeable membranes, selectively allowing CO2 molecules to pass. Final product: purified, high-grade biomethane. From a pungent slurry, a clean energy source.
The next door hissed open, revealing a spectacle of controlled power. This hall now roared to life.
Each of these engines is a powerhouse, driving pistons that turn a crankshaft, generating electricity.
Rotational energy is converted into electrical energy, ready to be fed into the grid.
We need to increase the flow rate to the main grid.
The holographic readout confirms stabilization. Proceed with caution.
Engineers meticulously monitored every aspect. We constantly adjust our output to match demand and grid stability.
But the methane gas was not the only valuable output. A different kind of transformation was underway.
These contain the digestate, the rich, dark, nutrient-dense residue. This is our organic gold.
After the methane has been extracted, what remains is an incredibly potent fertilizer.
The digestion process eliminates most pathogens and weed seeds, making it incredibly potent.
Farmers in the surrounding regions eagerly purchased it, using it to enrich their fields.
It's a complete cycle. Cows eat grass, produce manure. We extract energy, and the enriched manure helps grow more grass.
Dr. Sharma stepped forward as the applause subsided. He articulated the heart of our operation.
What started as an ambitious dream to harness the overlooked potential of cow dung has blossomed into reality.
The impact on our community has been profound. Cow dung, once a burden, is now a valuable commodity.
Farmers are generating a new stream of income, strengthening their livelihoods and boosting profits.
Their reliance on expensive, damaging chemical fertilizers has plummeted, enriching their soil naturally.
Beyond immediate economic benefits, environmental dividends are immense. We are directly tackling climate change.
We are capturing vast quantities of methane, a greenhouse gas far more potent than carbon dioxide.
This factory offsets thousands of tons of CO2 equivalent annually, reducing our dependence on fossil fuels.
This, my friends, is just the beginning. What we've achieved here is a scalable blueprint,
Imagine rural communities worldwide transforming agricultural waste into energy, creating local jobs and fostering food security.
From small-scale community digesters to large industrial plants, the technology is adaptable and proven.
The methane miracle represents a paradigm shift in how we view waste, energy, and our environment.
It's a powerful reminder that solutions to our most pressing challenges often lie hidden in plain sight.
As we look towards a future grappling with climate change, sustainable innovations offer a tangible path forward.
The methane miracle stands as a testament to human ingenuity and sustainable progress.
From waste to resource, from challenge to triumph, a greener future is now within reach.